And good afternoon, Burnley. A pleasure to be here this afternoon to talk to you about the great moon hoax. There are quite a few people in the world, apparently, who believe the moon landings of the 1960s and 70s did not take place, but were hoaxed, faked. And people who believe this particular conspiracy claim to have lots of evidence. And there are books and web pages, thousands upon thousands of web pages that say it never took place, it's a conspiracy, here's the evidence. What I'm doing this afternoon as a scientist is saying, well, if they claim this is the evidence, does the evidence stand up to scientific scrutiny? So what we're talking about is the late 60s, early 70s. We're talking about, of course, the first moon landing in 1969. So let's first remind ourselves what happened 56 years ago. That was the rehearsal you didn't see on TV because they got it right second time, and that's the one that was transmitted. Or at least that is the claim, that basically everything you think you know about the moon landings, the images, the videos, etc., were all taking place on a soundstage somewhere. Perhaps Hollywood, a little bit too public, so maybe Area 51, they set up a soundstage, and that's where they filmed it all. Amazingly enough, if you take a survey of Americans, something of order 10% of Americans have doubts that it actually happened. And these are the Americans, not the rest of the world. This is the nation that supposedly achieved this feat. So the question is, why would you hoax it? Well, the reason it's a hoax is because
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
Kennedy made that promise in the early 1960s. But, as he said in that speech, it's going to be impressive, yes, and important, yes. But it is going to be difficult and it is going to be expensive. And it is claimed that they simply underestimated how difficult and how expensive it was going to be. So when it was realized in the late 60s that they weren't going to be able to achieve a moon landing and bringing the astronauts safely back to Earth, it is claimed that that's the point at which the Americans hoaxed the moon landings to basically try and hoodwink all of the American public and essentially the entire world. So there's no denying that this took place. There's no denying that Saturn V rockets have left the Earth. Millions of people have seen these live. Unfortunately, I never got to see one of these leave the Earth, but millions of people experienced the launch of a Saturn V, so it's difficult to deny that ever happened. Similarly, this is genuine. This is the Apollo hardware, one of the Apollo astronauts there doing some tests, and you can see the Earth in the background. So this is a test of the Apollo hardware whilst it was in orbit around the Earth. Again, that is not being denied. But those who believe in the moon hoax conspiracy basically say, no, there was never a picture of the lunar module sitting on the surface of the moon. That is just a big airfix model or something. It's not actually the real thing. And any picture you think you see of an astronaut bouncing around on the moon, that's just a video taken on this soundstage. And then they try and point out faults with the images or faults with the movies to say why these are faked images. So we're going to look at the evidence that people keep on regurgitating. There's an awful lot of it, and I've only chosen a few of the most popular points that are raised in arguing about the moon landings being faked. And those are: computers were not up to the task, radiation would have killed the astronauts, and also there's lots of videos that appear to be wrong, and there are loads of images that appear to be wrong for various reasons, some of which we're going to look at. So we're going to be looking at those pieces of evidence, asking ourselves, well, if people claim this is the evidence for the moon landings not having taken place, let's see if it stands up to scrutiny. So firstly, computers. It is said that computers were not very good in the 1950s and 60s. Well, they were certainly not capable of as many calculations as computers today. And yes, it is often said that you've got more computing power in the mobile phone in your pocket than was available at the time. Full-scale computers in the 1950s were huge. They would occupy a room half this size, for instance. So it's said that you couldn't possibly miniaturize it down to the size of a briefcase in order to get it inside an Apollo spacecraft. So that's the Apollo guidance system, the Apollo guidance computer that was supposedly responsible for doing the calculations. To say that it is slow and not much memory and can't do many calculations, well, that's true by modern standards. Your phone can do billions of calculations a second. This could only do thousands of calculations a second. So your phone is 1,000,000 times faster. How much information can be stored? A similar sort of thing. The amount of information that can be stored on your phone is millions of times more than the amount of information that can be stored in this computer. But to say it wasn't up to the task is simply misunderstanding what its job was. Its job was not to give you a very fancy interface and run the Mac operating system or Windows 11 or whatever. Its job was just to do calculations. The information went in on this keypad on the right. You can judge the size of that computer from the size of the keypad. Remember, astronauts might have gloves on, so it's a fairly chunky keypad. But information was typed in that way, and then information appeared on this panel on the right. Its job was just to calculate navigation. In other words, we want to go from here, where we are now, to there, where we want to be, and we've got a rocket with a particular thrust. How long do we have to fire that rocket, and which way do we have to point in order to get us from where we are to where we want to be? Basically, the equations that allow you to do that are relatively straightforward. It's not rocket science. Okay, it is rocket science, but rocket science is not as hard as people would have you believe. The calculations you have to do, basically Isaac Newton worked out the equations of motion. If you apply a particular force to a body of a particular mass, you'll accelerate in a given direction and you'll end up changing your position. Calculating how to do that is not that difficult. We ask our first-year students at university to effectively calculate how they need to fire a rocket to get them to Mars or to get them to the moon or to get them somewhere else. So it is possible, and it was known how to do it hundreds of years ago. And a computer that is capable of many, many thousands of calculations a second is perfectly capable of working out how you get from the Earth to the moon and land with a precision of a few tens of meters. So if anybody says that wasn't up to the job, that is not evidence. That is simply a statement, and the statement is wrong. It was up to the task. Second piece of evidence, the radiation belts around the Earth would kill the astronauts. Yes, the Earth has a magnetic field, and as a result, it tends to catch some of the charged particles that are coming out of the sun. There's a continuous radiation of charged particles from the sun. Some of them get caught in the Earth's magnetic field, and you end up with a belt, a sort of couple of donuts, if you like, around the Earth, where there is a significant amount of radiation. And it is said that astronauts couldn't possibly have gone to the moon because these radiation belts are lethal and the astronauts would die. Well, it is true that the Earth is surrounded by radiation belts, but the astronauts don't spend very long in these radiation belts. They get launched from the Earth. They're traveling at some 25,000 miles an hour on their way to the moon, so they'll only spend about half an hour or an hour traveling through these radiation belts. And if possible, NASA will try and arrange it so they don't go through the densest part of the belt, but will go north or south and just clip it. So yes, the astronauts do receive a radiation dose for about an hour on the way out and about an hour on the way back. But it's not significantly higher than, for instance, the radiation you might receive if you have a chest X-ray or that sort of thing. So this is another example which is not evidence. It's a statement. The statement is the radiation would kill the astronauts, and the statement is wrong. So again, not evidence. Let's look at what we could regard as evidence, videos and images. Let's start with the videos.
Maybe it'll that's what it looks like it's waving in a breeze.
How many times can a man turn his head and pretend that he just doesn't see? The answer, my friend, is blowing in the wind. The answer is blowing in the wind. Yes, and how many deaths will it take till he knows that too many people have died? The answer, my friend, is blowing in the wind. The answer is blowing in the wind.
With no atmosphere on the moon, flags should not be fluttering in the breeze. But this particular set of clips here, they have a common theme. I once asked in a school, what's common about all of these 4 clips? And I was told by a young kid, well, they're all the American flag. There's no Union flag there at all, which is true enough. That's one thing they have in common, that there's no Union flag on the moon, yes. But here, the main link here is the fact that in all of these clips where the flag appears to be moving backwards and forwards, there's an astronaut hanging on to them. They're either trying to plant the flag pole into the ground, or they're trying to unfurl the flag, or they're trying to get it to hang neatly for a nice photograph. Whenever an astronaut lets go of the flag, it might bounce backwards and forwards for a while, but then it will stop. If you really believe this is a sound stage, then why would they photograph the flag fluttering in the breeze because somebody forgot to shut a door over there? Why would they not simply destroy that footage and take it again when the flag had settled? So it's rather odd that people can claim that this is proof that these were not taken on the surface of the moon. Another short video, which people say that can't be right, is looking at the return of Apollo 17 from the surface of the moon.
Okay, quick. Take it on the desk. Okay, I'm going to get the pro. 99, proceeded, 3, 2, 1. Ignition.
If that,
That's good.
why is there no flame coming out the back? Why is there no exhaust from this engine? If this engine is firing and lifting the ascent stage of the lunar module off the surface of the moon, why does there appear to be no rocket engine there? There's no plume. Because, well, it is said that either there's no plume there, it's just the ship itself and no sign of a rocket exhaust, because it's just an air-fixed model. It's somebody with an air-fixed model on the end of a fishing line, and all they're doing is pulling it up from the model, and that's what's being photographed here. The claim that this is all wrong is based on the fact that everybody expects rockets to produce an exhaust out of the back. I mean, let's face it, what we normally see on Earth, that's a real man's rocket, that is. Look at that, white hot tongue of flame coming out of the back. Well, that's because it's nothing to do with are you launching on Earth or are you launching from the moon. It's nothing to do with the environment. It's all about the fuel. In this case, a Saturn V rocket is burning kerosene. It's a sort of paraffin. It's an aviation fuel, if you like. It's a hydrocarbon. And when it's burnt, you get white hot carbon products coming out of the back. And that's why it glows white like that. But if you're burning different fuels, you won't necessarily see a plume coming out of the back of your rocket engine. For instance, the shuttle didn't burn paraffin, it burnt hydrogen. And hydrogen, when it burns in oxygen, produces water, and water vapor is transparent, so effectively you don't see any exhaust. If we have a look at the shuttle, you might say, how can you possibly say there's no exhaust there? Surely we've got white hot tongues of flame coming out of the back of the shuttle. Well, no, look a little more closely. The white hot tongue of flame are coming out of the boosters that are on the side of the tank. The shuttle itself is got 3 engines and they are going full tilt, and yet you can't see any exhaust coming out of those 3 engines. If anything, you get just the slightest hint of a shockwave in the exhaust, which is effectively transparent. So the point is, depending on the fuel you're burning, you might not see any rocket exhaust. So the fact that we didn't see any from the lunar module coming off the surface of the moon is not evidence that it can't have been a real rocket, but must have been a model. Let's have a look at a few images. This is really what got me interested in the first place, because I've spent a lot of my research analyzing images, not necessarily of the moon. I've been analyzing images taken from microscopes or telescopes or other things. But I got interested in this idea that the moon landings were faked because the images are all wrong. And this is one that crops up quite a lot, people claiming that the shadows are wrong. In the distance, we have the lunar module. There's actually an astronaut there, but he's so far away you can hardly see his shadow. But I think it's clear that the lunar module is casting a shadow to the right, indicating that the sun must be on the left. If the sun is the only source of shadows, and the sun is a long, 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 long way away, then surely all of the shadows should be parallel to each other, because there's only one light source a long way away. And those shadows should either be parallel and look parallel, or possibly converge to a point because of perspective. But if you look at these shadows, the shadow of the lunar module appears to be horizontal, but look at the shadows of some of these other rocks. Is the sun really there? Surely not. The sun must be outside the field of view. And if you look at some of the rocks in the foreground, well, they don't even seem to go to the same place. How can these shadows all be produced by the same object, the sun? It is claimed that when they put this sound studio together, they had more than one spotlight. And one spotlight was illuminating the lunar module, making a shadow, and another spotlight was illuminating the rocks in the foreground, making a shadow in a different direction. You could then ask, well, if that was the case, why do none of these rocks have 2 shadows? But if you ignore that for the moment and say, if you believe that is a real picture taken from the surface of the moon, then there must be an explanation as to why those shadows look the way they do. They don't look parallel, and they don't look like they're coming from the same place. Surely all the shadows should be parallel to each other if there's only one source of illumination, the sun. Some people say, well, what about the Earth? Yes, the Earth is in the sky, but doesn't produce anything like the same amount of light as the sun. It's a bit like here on Earth, sunlight is millions of times brighter than moonlight. Moonlight might look quite bright when you've got a dark sky, but it is in fact much, much, much fainter than sunlight. So if you've got the Earth and the sun in the sky at the same time, you won't see any shadows from the Earth. So if that is all from the sun, how do we explain the fact these shadows are going in wonky directions? And I rather like the explanation here, because rather than coming up with any particular weird and wonderful mathematics or any other explanations, somebody figured out the simplest explanation is to show how it can happen by making a small model of what's going on his kitchen table. So he made a little airfix model, and it's got a shadow going off to the right. There's a pen in the foreground, and the pen is only there to show you that its shadow is also going off to the right, which shows you that the light is way off to the left. It's a spotlight many, many meters away on your left-hand side, and that's the flat kitchen table. But what if the shadow is not falling on a flat kitchen table? What if the shadow is falling, in this case, onto a lump of plasticine, indicating that these little rocks here are actually sitting on a little bit of a mound? In that case, the shadows, despite the fact that they're produced by the same light that's producing this shadow and that shadow, these shadows appear to be at jaunty angles. So, is the explanation that this image is a fake, or is the explanation simply that the particular bit of the moon we're looking at is not as flat as a kitchen table? Maybe there's a little bit of a mound here that we can hardly make out. It's not a 3D picture, it's just a normal 2-dimensional picture, and maybe these rocks are casting their shadows on ground that is falling away ever so slightly, and that's why the shadows appear to be at odd angles. If it can happen on a kitchen table, Why can't it happen on the surface of the moon? So this is not evidence that the images have been faked. Another favorite that keeps cropping up over and over and over again is, if this is a picture of the lunar module on the surface of the moon, why are there no stars in the sky? If the moon has no atmosphere, surely the stars should be even brighter than they would appear on the best night on Earth, and therefore they should be blazing away in the background. That's the claim. There's actually two misconceptions here in this set of statements. One is the assumption that if there's no atmosphere, the stars will be brighter. The atmosphere of the Earth doesn't absorb much light. Our eyes have adapted to see visible light because most visible light from the sun gets through the atmosphere. Not necessarily 100% of it, but 90-something% of the light hitting the atmosphere gets through to ground level. In other words, the atmosphere is essentially transparent. Therefore, if you took the atmosphere away, the stars wouldn't be much brighter. They'd be a tiny bit brighter, but it wouldn't really make much difference. So on the moon, at best, we would expect the stars to be about as bright as you would see them from the Earth. So come back to the question, why aren't they visible? Well, think about it. There's a man in a white suit standing in front of a rather reflective lunar module in direct sunlight. It's always sunny on the moon, never cloudy. It's always sunny. Therefore, whenever you take a picture, you're taking a picture of somebody in direct sunlight. It's like taking a picture on Earth in the middle of the day with the sun beating down. Anybody that's ever been involved in photography knows that regardless of whether you're dealing with film, as in the case of the 1960s, or a digital camera in the case of the present day, you would still be talking about taking pictures during the day with an exposure that's tiny, perhaps 1,000th of a second, or something like that. In direct sunlight, nice bright day, therefore your exposures will be very, very short. But if you wanted to take pictures of stars, anybody that's ever tried to do any nighttime photography or any astrophotography and take pictures of stars and nebula and galaxies, etc., the exposures need to be, with the lens fully open, the exposures need to be usually minutes, occasionally hours. Certainly not a tiny, tiny fraction of a second, which would be appropriate for the man in the suit and the lunar module. So why no stars? Very simple. The exposures are just too short, which is exactly what you'd expect for a sunlit scene. You can turn this around and say, well, if you really believe that this is evidence that this was taken in a sound stage, if NASA have faked this, why did they take a picture of an astronaut in front of a lunar module in front of a black backdrop? Why didn't they paint the stars in? Why didn't they actually have a backdrop with some stars in the right position? Surely that would be the simplest thing to do, and then nobody would be arguing, hang on, why are the stars missing? Well, some conspiracy theorists say, yeah, this is definitely fake, and NASA didn't put stars in the background. Why not? Well, they didn't want to get it wrong. In other words, what they didn't want is loads of amateur astronomers coming along decades later saying, hang on, those stars are in the wrong place. If that's a picture of the lunar module, that star shouldn't be there, it should be over there. Now, if you really believe NASA don't know where the stars ought to be, you have a very low impression of what NASA's capability is of getting men to the moon. So again, it doesn't really stand up to any sort of scrutiny. Another one that crops up fairly regularly is, this appears to be an astronaut on the surface. It's actually Aldrin. It's an image taken by Armstrong. And there's clearly footprints everywhere, quite a few centimeters deep. Astronauts leave footprints in the lunar regolith, the soil, if you like. And yet, the lunar module, and I presume this is the leg of one of the lunar modules, it has a big landing pad, and the landing pad doesn't appear to have gone a few centimeters into the regolith. Why is it that astronauts leave footprints, but the lunar module doesn't? You can do a quick calculation and you can figure out, well, the lunar module is heavier, but its weight is spread over the big landing pads compared to an astronaut who has big boots on, and you can calculate the pressure under the astronaut's boot and the pressure under the landing pad, and they're very similar. So you might expect them to go a similar depth into the regolith. So this is basically shown as proof for the conspiracy theorists that it must be a soundstage because this is simply a prop on the right-hand side and the astronaut has been kicking up footprints, etc., in the dust. So the simple answer to, well, if it's possible to actually make footprints into the soil, why didn't the lunar lander leg sink into the soil? The simple explanation is, well, sometimes it did. It's just that you can't see it in the previous image. There are plenty of images that show the pads at the bottom of the legs of the lunar lander did sink a few centimeters into the regolith. It depends exactly how compacted that regolith is. Much like on Earth, soil can be quite compacted or quite fluffy. So in this particular case, people are saying that image doesn't show it, therefore there's a problem, as opposed to some images do show it, some images don't, therefore it's not really evidence. It's a question of just picking the particular images that make your point and ignoring the images that don't make your point. I have found from practice, from experience, that this is the way a lot of conspiracy theory arguments go. They will take the evidence that makes their point, they'll ignore the evidence that doesn't make their point, or is a counter evidence. So that doesn't work either. Let's have a think of the cameras that are used by the Apollo astronauts. The Apollo astronauts have a camera bolted to the chest plate. They don't want to have to keep carrying the cameras around, so it's much easier to bolt it to the chest plate. And the camera is a variation of the Hasselblad made in Sweden at the era, and they were modified for use by the astronauts. If we make that image on the right a little bigger, you can see it a little more clearly. There's no viewfinder on the top of the camera. The astronauts are wearing helmets and they can't look down. So they can feel what the camera is doing. They have paddles on the lens focus and the shutter control and the aperture control, all manual, of course, no automation here, no auto exposure, no auto focus. So the astronaut sets the focus and the shutter speed and the aperture, and that's done by paddles on the lens itself. But the astronaut can't look at a viewfinder because there isn't one. And there's no need for a viewfinder because even if there was one, the astronaut wouldn't be able to see it anyway because it's effectively too close to him. So when an astronaut wants to take a picture, he simply points his body in the relevant direction and hopefully the thing in front of him is the picture that he's going to take. But one particular point about these cameras, perhaps you can see it in this image, every once in a while you see these black crosses. There's a few of them here. You can't see them in the original image because they're probably too small. But these black crosses are made in the camera. If you're the lunar landscape, then the light comes from the lunar landscape through the lens of the camera. Before it hits the film, it goes through a glass plate onto which are etched these black crosses, so-called fiducial lines. They're calibration lines. It gives anybody analyzing the image an idea of what they're looking at. There's lots of crosses, some of which are visible and some perhaps not. There's lots of crosses on this image, and if anybody is inspecting this image, they can get an idea that, oh, that image has definitely been cropped because I can count how many X's there are and I can see there's more this way than that way. And one of those X's, one of those crosses, is bigger than all the others. That's the one in the center of the image. So it makes it easier to analyze and figure out, well, how big is that rock I'm looking at if it's the same diameter as the distance between one cross and the next. So why am I telling you about these crosses? Because the crosses are in the camera, and yet when you look in detail at some images, let me blow that up so you can see it better, that X, that cross, appears to be behind the white object. Doesn't matter what the white object, it happens to be an antenna on one of the lunar rovers. But the black cross is in the camera, and the lunar rover is out there somewhere. So the black cross cannot be behind the white object, and yet it appears to be so. And this is one image that I saw compared to all the others where it only takes a few seconds thought to say, yeah, I can see why that is actually not right. I can see the shadows are okay, even though they say they're not. This one is one that made me think, yeah, you're right. The black cross can't be behind the object. That doesn't make any sense. You can still ask the question, well, how did NASA get it wrong? I mean, was somebody responsible for just drawing these black crosses in and got it in the wrong place? But again, the best explanation, rather than getting too technical, is to demonstrate, and again, kudos to the person who worked this out, to demonstrate how it can happen. And this person demonstrated it by going into his garden and taking a picture of a grey piece of card and a white piece of card, in front of which was a washing line. When the washing line is in front of the grey card, I hope you can see it. When the washing line goes in front of the white card, it all but disappears because the white card is overexposed. And whenever you overexpose film, or to a certain extent digital cameras as well, it can be possible for the overexposed bit of film to bleed into the neighboring regions and, as it were, fill in the black and make it look white. It's simply a property of how film works, and it's also something that can happen in digital photography. So the fact that the object appears to disappear behind the white is just an illusion. Same is true here. The white is overexposed and is filling in the black mark, making it look like the black mark has been behind the white. So this particular phenomena does occur a few times in Apollo images. And whenever you see a black cross that appears to disappear behind something in the image, it's always an overexposed white object. Those black crosses never disappear behind a grey rock or something else. If they disappear because of overexposure of a white part of the image. So it took a little more explanation than simply saying that's obviously okay or that's obviously wrong. But again, there's a perfectly reasonable explanation which has got nothing to do with the fact that these objects were taken on the moon, because we see exactly the same results if we set up the problem correctly when we take a similar image on the Earth. It's often said that if these cameras bolted to an astronaut's chest plate don't have a viewfinder, how do they get such perfect framing? How do they get framing of the things that they're trying to photograph that are basically spot on? Here's a picture of Aldrin, second man on the moon, taken by Armstrong, the first man on the moon, taken during Apollo 11, allegedly. Anybody not ever seen that picture before? I've seen that picture so many times since I was a teenager. Yep. I would hope that picture has been around the world so many times. It is the iconic picture of man on the moon, basically the first mission. But you can ask, how did they get the framing right? And the answer to that, let's just take a slight aside. Let's look at two images of Aldrin taken by Armstrong. I've cropped them differently, so one is the full square and the other one is a rectangle taken from the square, and I've made them a slightly different size in order that Aldrin looks a similar size because they're taken at slightly different distances. So here, Aldrin on the left and Aldrin on the right, they were taken a few minutes apart. So Aldrin has changed his pose. In one case, he's looking sort of at the side, and then he's turned slightly to face Armstrong to get a slightly better picture, and his arms in a slightly different position, etc. But there is one key difference between those two images that tells us something is wrong. And the thing that is wrong, I'll give a second to ask if you can tell the difference. It's perhaps not showing up brilliantly well on this projector because it's a question of the contrast of the image, but there is quite definitely an aerial sticking up from the backpack on this one. I'm not sure how well it shows up from the back, perhaps. There is definitely a very thin white aerial coming up there, but there is no sign of the aerial. It's not just a question of the projector. Even if you look very, very closely, there is no sign of the aerial there. But the aerial is white, and it's a radio aerial. It's white, and it's visible from all directions, and it's sunlit. And it must be there because it's the radio antenna that allows the astronauts to talk to each other and to talk to the mothership in orbit and ultimately talk back to Earth. If that radio antenna had been damaged or folded or broken off, they would have curtailed the moonwalk immediately because it would be far too dangerous to do a moonwalk without radio communication. So that radio antenna must be there, but there is no sign of it whatsoever in that image. So I'm coming back to, how did they get the framing right all the time? And the answer is they didn't. That is not the picture taken by Armstrong of Aldrin of the surface of the moon in Apollo 11. The actual image, which you can get from the NASA archives if you wish, is because we can see the center of the image is down there, which is not the center of the actual square, the real image was actually that one. That's what's in the NASA archives. And so you can see that his foot is in the middle of the image. That's where the biggest cross is. I know you can't see it, but that's where the biggest cross is. So Armstrong accidentally chopped off the top of Aldrin's aerial. I know that sounds bad, but no, he's just, in this picture, he chopped the top. It's like taking a standard picture of your auntie and chopping the top of her head off. It's the same sort of idea. Perhaps Aldrin was on slightly different ground. Maybe Aldrin was on higher ground than Armstrong. Maybe Armstrong was leaning forward slightly. He's got 100 kilograms of life support backpack. Yes, I know gravity is less on the moon, but still it means your center of gravity is such that there's a tendency just to lean ever so slightly forward. So maybe this camera was pointing down slightly, Aldrin was on slightly higher ground. As a result, Armstrong took a picture of Aldrin's foot and chopped the top of his head off, top of his helmet off, and the top of his backpack with the aerial. NASA said, that's a fantastic picture. Let's look at the next one Armstrong took. Well, it wasn't another picture of the same thing. It was a completely different picture of some piece of equipment. In other words, Armstrong was doing what he was supposed to do, take a picture of the lunar module, take a picture of the rocks, take a picture of the astronauts, etc. He never took a second picture that looked like that. But NASA thought that's a fantastic, iconic image of Aldrin with the reflections in his visor, etc. We want to use that. But aesthetically, that doesn't look very nice. So what they did was take the original image, print it, and then basically add some black to the top. No stars visible, so you don't have to paint the stars back in. So all you do is print it out, print out some black, rephotograph it. Remember, no Photoshop back in the 1960s. You couldn't just put it into a computer, add a black rectangle, Bob's your uncle. It was a little more problematic, but it is possible. And basically, they just added the black at the top and reframed it to give them a more aesthetically pleasing result, because nobody really liked the original. So that is the one instance where NASA have admitted to doctoring a photo purely for aesthetic reasons, nothing to do with trying to make it sound like we're hoaxing the whole moon landings. So that's happened quite a few times. If you look in the NASA archives, you find lots of instances where they haven't framed things correctly. They thought they were pointing at this, they were actually pointing slightly off. There's plenty of examples where the framing is not quite right. And so this is one example. Usually they're fairly good because they get used to always pointing their body where they want rather than pointing the camera where they want. So yes, they don't get the framing right. So you could ask yourself, okay, looking at all the evidence that people say, here's evidence that the images are wrong, the video's wrong, the computers are wrong, the radiation would have killed them. If you look at all of that evidence, there are very simple explanations to why that evidence is not evidence of the moon landings being faked. But you can turn it around and say, I am not convinced by any of this so-called evidence because common sense tells you that this isn't indication of a hoax. So you can turn that around and say, could you possibly present any evidence that does, beyond any reasonable doubt, prove that the moon landings did take place? But the problem there is it depends what you mean by reasonable. Because when you're talking to a conspiracy theorist, they very rarely say, well, the evidence you presented has convinced me I'm wrong. Scientists, hopefully, will take evidence, weigh it up, and then decide which is the strongest evidence, whether a hypothesis is true or a hypothesis is false. Generally speaking, I have found that conspiracy theorists believe what they want to believe, and no amount of proof will sway them beyond that. So the question is there any proof that we did actually go to the moon and astronauts have set foot on the moon? What about this one?
Well, in my left hand, I have a feather. In my right hand, a hammer.
Feather, hammer.
One of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? That proves that Mr. Galileo was correct in his findings.
Here they dropped a hammer and a feather, and they fell at exactly the same speed, hit the ground at the same time. Do that on Earth, the hammer will fall faster and the feather will flutter to the ground because of air resistance. So, a hammer and feather experiment, is that proof that this was done on the surface of the moon? Well, you could argue, no, it's not proof that this was taken on the surface of the moon for two reasons. One, you could argue that this must have been taken in a vacuum in order for the hammer and feather to fall at the same rate. Or you can say, no, how do I know that's a hammer and feather? I've only got this guy's word for it. He's a NASA employee. Of course he's going to be in on the conspiracy. He knows he's not on the moon. So you could argue that no, that is not proof. It's an indication it was done in a vacuum, or somebody is cheating. So you can't simply take a video, even a rather poor resolution video like this one, and you can't use that as proof that we've actually been to the moon. The closest thing I could find of proof that we've been to the moon is actually this. There's no audio on this particular one. It's an astronaut in a lunar rover kicking up some dust and skating over a large part of the lunar surface. I've taken a crop from this video because the video is actually quite long. The reason I think this is good evidence that we've been to the moon is, I'm not going to show you, but scientists have taken this video frame by frame by frame and looked at the dust kicked up by the wheels. You do this on Earth, the dust kicked up billows because of its interaction with the air molecules. Here, every tiny bit of dust that's kicked up by the wheels goes into space and follows a parabolic trajectory and comes back down again, completely unimpeded by any atmospheric effects. And that happens for the entire video. So I think undeniably, given that it would have been very difficult to fake a video like this in the 1960s, that video shot was done in a vacuum. So if that was done in a vacuum, is it proof it was done on the moon? Well, this video is quite a long video. It shows an astronaut driving the lunar rover from some distance away and coming past the camera and driving some distance away. If this was photographed or videoed in a vacuum chamber, the vacuum chamber would have had to have been huge. It would have to be hundreds of meters long and many tens of meters deep and possibly tens of meters high as well. And you could say, well, that would have been tricky to actually generate a vacuum chamber that big. I would agree. You could also say, technologically, rather than build a vacuum chamber in which you can photograph that hoax, it would have been easier to go to the moon and photograph it properly than it would be to build a vacuum chamber and try and fake it. So I think that's as close as you get to proof that it actually happened, because the alternative is simply a far more difficult technological challenge than sending 3 people to the moon and bringing them back safely. Some people say, well, isn't it proof that we have reflectors on the moon? Some astronauts have left these reflectors so that if you fire a laser at the moon, the laser comes back to the original telescope that fired it. And if you measure how long it takes light to go to the moon and back, you know the distance to the moon very accurately, because we know precisely what the speed of light is. That's been done every day for the last 50 or so years. Somebody somewhere has been sending a laser to the moon and back and measuring the distance to the moon to an accuracy of about a few centimeters. So we have known the distance to the moon and the distance to various sites on the moon to an accuracy of centimeters every day for the last 50 years. So we've got a very good idea of how the moon is moving, and because we're looking at the distance to different points on the moon, we also have a pretty good idea of how it's rocking from side to side and nodding backwards and forwards as well. A very good test of our understanding of gravity. That certainly has happened. Is that proof that those reflectors were placed by Apollo astronauts? No, it's effectively proof that those reflectors are there, but maybe they were placed there by robots rather than by astronauts in the 1960s. Again, it's not actually proof that the Apollo astronauts have been there. It might have been a robotic mission, an autonomous mission, an uncrewed mission, which actually sent that equipment to the surface of the moon. Another common counter-argument is, Well, look, if they really do have the descent stages of lunar modules sitting there, if there really are flags planted in the moon, if there really are footprints there, why doesn't NASA just task the Hubble Space Telescope to point at the sites on the moon so that it'll be established once and for all that we can definitely see the flags and the footprints and the lunar module, etc.? NASA have always refused to point the Hubble Space Telescope at the landing places on the moon. And the conspiracy theorists say, ha, there you see, they're not going to point the Hubble at the moon because they know they'll get just a blank bit of terrain, and that's proof that we've never actually gone there and never actually landed. No, that's not the reason NASA refused to point the Hubble at the moon. They refused to point the Hubble at the moon because of a very basic element of physics. And whether you believe the moon landings or don't believe the moon landings, everybody has to obey the laws of physics. That's just the way it is. And if you don't like a little bit of maths, look away now. We can calculate what's the smallest thing we could possibly see with the Hubble Space Telescope. It depends on how big the mirror is and the wavelength of light. And we can calculate that the smallest thing we can possibly see with the Hubble Space Telescope, the smallest angle that we can resolve, is 0.2 millionths of a radian. You don't know what a radian is, so let me change it to 10 millionths of a degree. That's the smallest thing we can possibly resolve. That's why we get such great images of galaxies and other objects in the Milky Way or galaxies beyond the Milky Way. But if we convert that, because astronomers tend not to use degrees, 1/60th of a degree is an arc minute, and 1/60th of an arc minute is an arc second. And astronomers tend to use arc seconds. So let's convert it into arc seconds. The smallest thing that the Hubble Space Telescope can resolve is 0.05 arc seconds, the smallest detail it can see. What would we need in order to see the lunar module on the surface of the moon? The lunar module is, let's say, about 4 meters or so across, and the moon is 400,000 kilometers away. So we can calculate what would the angle made by the Apollo lunar lander at a distance of here to the moon, what angle of resolution would we need? And we do that same calculation, we see that we would need a resolution of 0.002, much smaller than Hubble can do. Hubble is incapable of resolving the lunar module on the surface of the moon. Yeah, Hubble is fantastic. It can see galaxies a long, long away. But the lunar module is not very big, and the moon is 500,000 kilometers away. The lunar module is not only too small to be seen by Hubble, it's too small by a factor of about 30. In other words, if the lunar module was 100 or 200 meters across, we would have a chance of seeing it. No flags, no footprints, but if it was 30 times bigger, we might just be able to make it out. Another way of saying it is the Hubble Space Telescope, instead of having a mirror a couple of meters in diameter, the Hubble Space Telescope itself would have to be 100 times bigger in order to give us the resolution to see the lunar module or perhaps the flag on the moon. So that's why Hubble, the NASA team, don't point Hubble at the moon. There is no point. We know from the laws of physics it is incapable of resolving that detail. There have since been lunar orbiters which have shown the landing sites, but conspiracy theorists would say, yeah, but the lunar orbiters, yeah, that's a NASA mission. They're faking that as well. So again, you cannot win. A little while ago, I showed this image from Apollo 12. Let me just make it a little bigger so you can see it a little more clearly. There's an Apollo astronaut with a sample, a sample soil canister in one hand. The sun is over his right shoulder, and therefore there's a little bit of flaring, because you can, whenever you have a bright object shining into a lens, there's always a possibility of some reflections. In the 1960s, lenses arguably weren't quite as good as they are today in dealing with reflection. So there's a big sort of pentagon next to his head, and there's a few lines in the top left, which are all the result of the sun shining into the lens. Apart from that, there is something very wrong with this image. I'll give you, again, a few seconds just to see if you can spot what it is. Here's an astronaut having his picture taken. His picture is being taken by one of his colleagues standing there taking the picture. Who's that joker in the background? There should only be 2 of them on the surface of the moon. Every Apollo mission has 3 people. 1 stays in the mothership, orbiting the moon. The other 2 go down to the surface in the lunar module. So at any given time, there can only be 2 astronauts on the surface of the moon. 1, 2, and another one in the background. So, you could argue, this image must be fake. How can it possibly be otherwise? If you've only got 2 astronauts, you can't possibly have 3 in the picture. Absolutely right. This image is fake. And I know it's fake because I faked it. I took that image from the NASA archives, which happened to have a nice little space there. I took that image from the NASA archives, did a little explore. Can I find another astronaut digging in the regolith? Yeah, I found another astronaut. He was too big, so I made him smaller. The sun was on the wrong side, so I flipped him over in, the equivalent of Photoshop, some graphic software. And so I found an astronaut and basically put him in there, and then tidied up the horizon so that it didn't look fake. It took me a couple of minutes with graphic software to take an image and fake it. Unfortunately, in this day and age, it is so easy to do that. Back in the 1960s, it would have been quite tricky. But as I'm sure you're well aware, now with the digital tools at our disposal, the imaging tools at our disposal, it is so easy to fake images. And it's rather tricky to tell they're fake, certainly at first glance. And one of the reasons I got interested in this whole business is it possible to look in detail at images and tell if they've been faked or not? But if I'm ever giving this talk to school kids, I remind them that there is nothing on the internet that they should believe is necessarily valid, because it is so easy to get things like this completely wrong. So what's the point? Why are there so many people, many percent of the American public as well as other people around the world, believe that the moon landings didn't take place? Is that an indication that there was something wrong with the moon landings, or is it an indication that a lot of people simply have a total and utter distrust of governments and they don't believe anything they are told by the government? Do they really believe the evidence that they say, here's evidence that the images are wrong, here's evidence that the videos are wrong? Do they really believe the evidence? Because it only takes a couple of minutes and a little bit of common sense to show, nope, that's not valid, that's not valid, that's not valid. All of your so-called evidence doesn't actually stand up to scrutiny. The arguments can be countered either with a little bit of basic physics, or usually just a modicum of common sense is all you need. So I would argue to school kids, it's a very nice way of getting used to the idea of critical thinking. If this person is making this claim based on this evidence, why don't you look at the evidence and decide whether that evidence actually backs up the claim or not? Don't take it at face value. Figure it out for yourself. Critical thinking is so important in an age where we're presented with stuff and we're told that this is evidence for X or Y or Z. We should really try and figure out for ourselves whether that is the case. Thinking about how things behave on the moon is sometimes a good science lesson for dealing with how things behave on Earth. And I started this set of talks by actually delivering it as a school's talk, and it's now morphed into a more outreach talk. So if you ever see this picture again, outside of this lecture hall with somebody who's not getting the inside track here, whenever you see that picture with a bit of black space at the top, you can say that you know that this is not the picture of Aldrin taken by Armstrong on the surface of the moon, and you can tell them why. Thank you very much for listening.